Okay, we're trying to show that if S is a sum of two independent random variables, that is x and y, two independent random variables, what it means that if we give an input and the system A is a random variable represented by x and system B is a random variable represented by y, basically what it means that we can get the output through either this random variable or through this random variable. Okay, if any one of the random variable, the system operated by any of these random variables work. Well, this is just an analogy. Our main task is to show that if S is a function of two random variables x and y, which is the sum of two independent random variables, then the PDF of S is given by the linear convolution of the PDF of x and the PDF of y. We're trying to establish this relationship. Okay. So in order to establish this relationship, we'll have to again first go for the CDF, the usual derivation, that is f of s is equal to probability of s less than or equal to s and s equal to x plus y, so probability of x plus y less than or equal to x. So we'll have to do double integration over this region. So we have to first identify this region. So how are we going to identify this region? We know that s is equal to x plus y. Okay, so we will have to first draw the line for s equal to x plus y. So this is the graph of s equal to x plus y. Okay, the graph of x plus y equal to s is given by this straight line. And our region is x plus y is less than or equal to x, s. Okay, so this is the line for s equal to x plus y. So x plus y less than or equal to s will be simply this region, the region behind this line, this complete region. So we will have to find the limit for this integration. If we look carefully, if we look very carefully, we will see that the limit will have to do integration in terms of both x and y. We have to do integration in terms of both x and y. So we will have to define the limits for both x and y. The limit of y will be simply from minus infinity to plus infinity. From minus infinity to plus infinity. Y varies from minus infinity to plus infinity. But the limit for x will not be from minus infinity to plus infinity. It will start from minus infinity, but it will stop at this straight line. This straight line is s equal to x plus y. So the value of x on this straight line is actually given by x equal to s minus y. Okay, let me repeat. Limit of y will come from minus infinity up to plus infinity. But the value of x, since we are moving in this direction, will start from minus infinity but will stop at this straight line. And this straight line is given by s equal to x plus y, so x equal to s minus y. Hence, this limit for x is from minus infinity to s minus y. The limit for y is from minus infinity to plus infinity. Okay. Since x and y are independent random variables, f of xy is given by f of x into f of y. We already know this. The multiplication of the marginal PDFs. Okay. We can now, what we can do is we can separate this integration. This part we can simply separate, and the idea is integration of minus infinity to s minus y f of x dx. This is called changing the order of integration. We can do this. This will still work. Okay. And this is the integration of the PDF of x from minus infinity to s minus y. So this is the definition of the CDF of s minus y. We know that the CDF of x, let's have a quick recap. The CDF of x is simply minus infinity to x integration of the PDF. Okay. So this integration is from minus infinity to s minus y. So this will become CDF evaluated as minus y into f of y. Okay. So this is the CDF of s. S is again the sum of two independent random variables x plus y. So now if we need to obtain the PDF, we will have to differentiate this CDF. So we will differentiate this CDF f of s. Okay. So we will differentiate this with respect to s. Okay. So we can interchange again, we can take this differentiation inside this integration. This is again called interchanging the order of integration differentiation. This can be again done, it's mathematically feasible. So when we do this differentiation term, when applied on f of x minus y, because this term has no s in it, only as y. So this is not a function of s. Okay? Y is not a function of s. But this term has s in it. So this will be differentiated with respect to s. The CDF of s minus y, CDF of x evaluated at s minus y, differentiated with respect to s, simply gives the PDF of x evaluated at s minus y. So this is nothing but the definition of linear convolution. This is the definition of linear convolution. That is, f of x is reflected and then shifted on the y axis. It is reflected in terms of x and it's shifted in the y axis. Okay? This is nothing but the convolution of the PDF of x and the PDF of y. This can also be written thus. From minus infinity to infinity, we keep x as it is, and we can instead shift, forget this line, we can instead shift y. There are two ways of doing linear convolution if we have a quick recap. Okay. So we have been able to show that if s is the sum of two independent random variables x and y, then the PDF of s is given by the convolution, the linear convolution of the PDF of x and the PDF of y.